Alright, silly people, here's the situation. We have a cylinder, a right cylinder with radius big R and height h, um, and we're meant to find the height to diameter ratio for the cylinder such that the ellipsoid equation, this guy, um, becomes a sphere equation, where rho 1, rho 2, rho 3 are the principal axes, and then the I stuff are the components of the moment inertia tensor for this cylinder, which is that equation there. Um, so what does it mean by making it a sphere? Well, you want it so that Ixx is equal to Iyy is equal to Izz, and then the ellipsoid equation is a sphere equation. Uh, for a cylinder, Ixx is equal to Iyy anyway from symmetry. So we really only need to find Ixx and Izz in terms of these mystery variables, and then solve for h over d. Uh, so Ixx is then it's a volume integral of some mass distribution function, which I really don't care about, times r squared minus x squared dv. I'm going to do this in cylindrical coordinates. Why the hell not? It's a cylinder. Um, so x is going to become r cosine theta, and the integration bounds are from minus h over 2 to h over 2, 0 to 2 pi, 0 to r, and then it's r squared minus r squared cos squared theta. The integrating factor is r dr d theta dz. So there's no z in there. Oh, I forgot to write the mass distribution. Yeah, mass density. Um, I'm going to treat the mass density as constant. This can be any sphere or any cylinder, but I'm going to say that the density function is just a constant, so I don't have to deal with it. There's no z in this, so that just becomes h. The r integral, so you have r to the third on both of these things. So you're going to have r fourth over 4 for your result for the r integral. And then 1 minus cosine squared theta turns into sine squared theta. The result of that integral is just pi, so it's rho h r fourth pi over 4 for Ixx. Cool. Now Izz, which is kind of going to be a more interesting integral, I think. H over 2, 0 to 2 pi, 0 to r. I'm already calling rho constant. It's r squared minus z squared, r dr d theta dz. So the integrand is already in cylindrical coordinates, so this is just kind of evaluating. Notice there's no theta in the integrand, so I'm going to go ahead and pull out a 2 pi, right? And then looking at the r integral first, it's r third, no, r fourth over 4 minus z squared r squared over 2 from 0 to r dz. Okay. I don't know why I didn't just plug in the integration bounds. R fourth over 4 minus z squared r squared over 2 dz. Then that integral, now we're looking at 2 pi rho r fourth z over 4 minus z third r squared over 6. Okay, from minus h over 2 to positive h over 2. All right. Uh, so those are pretty cool. Let's just go ahead and start plugging stuff in. We'll have a lot of terms. R fourth h, 4 times 2 is 8, minus z, so h cubed, and then r squared over 48. Yeah. And then the minus stuff is pretty much going to be the same thing except with a minus sign on it. So it looks like we're just adding these together. Plus h third r squared 48. Adding them up, you're going to have r fourth h over 4 minus h third r squared over 24. And that's what we have to set equal to ixx. So rho h r fourth pi over 4. Isn't it nice that we can cancel out the mass density function? We'll even also go ahead and cancel out the pi. Let's divide both sides by 1h, just 1h. And even divide everything by r to the 4th. So this will go away and you'll have an r fourth on the bottom. And then multiply the equation by 4. So now we're talking about 8 8 times 1 over 4 minus h squared over 24 r squared equals 1. All right. I'll factor that 8 through, so we're talking about 2 minus h squared over 3r squared is 1. And then put the h squared over r squared on the other side, so it's 1 equals h squared over 3r squared. Multiply the equation by 3 and then take a square root. Root 3 is h over r. The problem does ask for you to put it in height to diameter ratio rather than height to radius, which does just mean height to diameter is 1/2 of that, so root 3 over 2. Nice.